the fundamental architecture of the universe. So basically, imagine you're standing in a big, vast, dark universe. Although I can't say empty, there are just no real objects in sight. So consider this. The entire universe is a field of energy. We already know energy can define existence in our universe, in our perspectives, based on all of our studies. So, what I do is, I try to condense all that energy into one point. I'm focusing on one point and condensing energy there. I either introduce a new object in that universe and bombard it to another object in this place, or some other technique, does not matter. I condense energy there. If I measure that and it exceeds a certain value, it excites. That energy which was normal, that energy increased for that particular region, which we call excitation. And if it reaches or crosses a certain value, we say it is like it exists now. It exists as a real particle. Basically, after a certain value, when we condense energy, existence means real existence. This is what we call a particle. Alright. Now then, using my instruments in the labs, I want to study this, I want to measure this, so I started. Then what I saw was, I'm not able to locate it. In the sense, when I try to detect in that region where that particle is, at each iteration, it shows a different point. For example, I'm detecting in this region. First reading was here, second reading here, third reading here, fourth. It's completely random. It's not like it's moving also. I don't know the reason for this. Why is this happening? And one more thing. Why is it showing as a point? It should not. It's just a region which has excited energy. Why is it a point? Why is it collapsing into a point when I detect it? Alright. For now, I'll give names so that I can visit back and understand later. For the point form, I say it's the particle. The region, the entire region where I can find the particles if I detect, the entire region, I'll say it is a probability cloud. You know why? I cannot understand exactly where the point is, because for each time I try to measure, it shows different and it's completely random. But that region is maintained. I cannot detect the electron somewhere else. It stays there, that region. So, mathematically, I can get a probability of this. Probability of where I can find the electron or the particle or the photon, whatever it is, in that region. This is probability cloud of particle. Alright, now that we are done with that, there was a time when a famous scientist, René Descartes, he invented Cartesian coordinate system. Most of you are aware of it, like that x-axis, y-axis, the graph thing. Alright, we can represent different things, understand the behavior of many phenomena, particles, how they act, everything. What I do is, I apply this there. I apply the probability concept to the Cartesian system to understand the behavior. I get something fascinating. It's a curve which is like a wave. I get a curve like a wave on the graph. 3D or 2D. I'm just plotting the probabilities of where I can find that point when I detect in that region, which comes out as a wave. And this is what I call waveform. Waveform of a particle is the probability wave of where where and all I can find that or expect for the particle to be detected in the region. I'm just plotting. This is a waveform. Alright, now I understood what a waveform is, what a point particle is. I have given two names. I understood that I have a region. In that region, I can find the particle anywhere. So for now, I'll keep it in my imagination as unsymbolic. When I say unsymbolical, I exactly don't know what it is or what's causing it. It's just there. I can feel it. In that region, there is excited energy which is abnormal for that particular field with respect to the other fields, other surroundings. Alright. For now, let's keep this. Before moving on further, there is something else which we can do. We can apply kinexis here. The mathematical aspect of kinexis. When I say that, try to understand this. Now, this region, when I try to detect it, I got as a point. That entire probability stuff, it collapsed into a single point when I detected it. When I have a point, I don't know its behavior in time, in the sense the speed, the momentum, whatever it is. And when it's in the probability cloud kind, that form, I don't know the position of it. Position is when I detect it, that is when I know the position. So then, I can give a conclusion for my current journey. I can give a conclusion. Basically, I cannot simultaneously know the position as well as the speed, momentum, whatever it is of a particular particle. And this is exactly the Heisenberg Uncertainty Principle. Nice, we just rediscovered it. So then, this explains something really good. Guess what? That universe which we imagined earlier, it's not calm. It's not a calm ocean of energy fields where it's just energy filled and calm. It's not that way. You know the reason? Our detection just now. If it is like a detectable point, it does not have speed or momentum. And if it is like a probability part or cloud thing in which we don't know where it is exactly, it's not like calm anymore. It can be anywhere. It's chaotic, which is exactly how our universe is. It's chaotic on the fundamental scale, and we just discovered that using this principle. Alright then, what happens? How chaotic is it? We have energy field. It's not like something brings out of somewhere suddenly and is a total chaos. No, I don't think it's that way. How exactly? Actually, it is that way. But then we have this law of conservation of energy where energy cannot be created nor be destroyed, and it is a fixed rule. But then how can energy suddenly be there and be chaotic? Something needs to disturb to make chaotic, right? And this is where we stop. The universe is not an ocean or a lake which we disturb and it moves. It's not. Because it's not water it is filled with, which we are like, we know about. It's not, it's energy. And the universe acts in a different way than a normal ocean or a lake, which needs disturbance to move. Alright. We are celestial architects. That does not stop us. We need to know how it is being disturbed. So then, I dove deeper. What I got to know was, the universe uses a cheat skill. Literally a cheat skill. It cheats this law of conservation of energy. First of all, it's something we humans have given. It's not like it was labeled and given to us by the universe. We have observed what happens in the universe and written it as a law that something this happens everywhere in the universe and does not change. Alright, let's keep it that way. What happens is, at the fundamental level, you can actually get energy out of nothing. It is possible. How? The universe has a hidden rule. It's like, imagine being inside a sphere of ice. This sphere of ice is our universe, and the ice itself is like energy which explains the existence of the universe. Alright, I got that much. Now I have nothing else inside. I am alone in the ice sphere. Due to some reason, I need something to exist which I can use. Only thing I have is the universe. It's empty. But I am aware of a cheat scheme which applies to our universe also. I can pluck out the ice of the universe itself, what it's made of. Like its fundamental structure, the universe's structure. I can pluck out what it's made of. But then, if I pluck out what the universe itself is defined by, it's not the universe anymore. We just say it's nothing. Which just basically means I'm getting something from nothing. So nothing exists anymore. Here comes the point. I can pluck out, but for a tiny amount of time. If I pluck out and re-establish enough fraction of a unit of time, the unit is millions and millions times smaller than something like a second. Such a small time, I can pluck out and keep it back. It does not affect the universe. Existence is not affected. The tiny bracket of time, it stays. Since we pluck out and keep it back in the tiny amount of time and there is no real existence there, we call this virtual phenomena. See, now I was actually fascinated when I learned this. A real particle, as I said, it crosses a certain threshold and it exists. Basically, it's energy. Even if it's a certain threshold and we call it a particle, waveform, probability, whatever, it's energy. Okay. So when I pluck out this fundamental energy from the universe for a tiny bracket of time, when I pluck it out, in that instant, it's a particle. I keep it back, yes, it's not real. It's a particle. It has crossed the threshold or something like something to exist. It just came in, it's back. It just happens. So I can call this a virtual particle. Yeah. For the entire universe, every position, every place, every area, every region, it's brimming with these virtual particles. It's everywhere. See, there is no restriction for the universe. At the fundamental scale, these virtual phenomena can happen everywhere. Everywhere. This is why it's chaotic down there. That's the gist of it. It's virtual phenomena. We have virtual particles. We have real particles. Their existence. The chaotic universe. Now we have built the fundamental architecture, structure of the universe. So now we know what the universe is fundamentally to the extent of our knowledge yet. So we have this vast open space with time which we actively observe with. It's filled with fields of energy everywhere in 3 dimensions. These fields are not calm but chaotic. with virtual particles popping in and out, everywhere at the fundamental level. And when at a particular point there is this extra energy or condensed energy above a particular threshold, that region we can say a real particle exists, which interacts within this universe with everything else physically, being it being existing in that particular universe, an existence of that universe, and that's it. The fundamental architecture of the universe concludes here. Celestial Architects signing off.